All right, so are you ready to do a deep dive into algebra? We're going to be looking at this textbook you sent me, and I got to say, it's really something.
Oh, yeah.
Like, this text is a treasure trove of problem-solving tools and tricks.
Definitely.
It's like, we've got this toolbox, and
Yeah.
today we're going to be, like, opening it up, seeing what's inside, and then figuring out how to use all these cool tools to,
Absolutely.
solve those tricky math problems we've all encountered.
The thing about algebra that I find so cool is that it's way more than just numbers and symbols and equations.
Right.
It's like a secret language that lets you express relationships and patterns.
Okay.
And once you're fluent in that language, you can unlock all kinds of problems, not just in math, but in like physics, economics, even everyday stuff.
Whoa, I like that algebra is a secret code to the universe.
Exactly.
So let's jump right in.
Let's do it.
The first tool we're taking out of our toolbox is solving linear equations. But before we get all equation-y, can you explain what makes an equation linear in the first place?
Oh, absolutely. So picture a graph, right?
Okay.
A linear equation is one that when you plot it on the graph, it always makes a straight line.
Huh.
And the reason it does that is because the variable in the equation, like x or y, has a power of 1. It's not squared or cubed or anything like that.
Okay, so linear equals straight line. Got it.
Yeah, basically.
The book then goes on to talk about solving one-step and multi-step equations.
Right.
Can we break those down a little?
Absolutely. Think of it like a balancing act.
Okay.
You've got your equation, and it's like a scale with two sides that need to be perfectly balanced.
I'm picturing it.
Whatever you do to one side of the equation, you have to do to the other to keep it balanced.
Keep it level.
Exactly. One-step equations are the easiest.
Right.
They're like a quick adjustment.
Right.
You can isolate the variable.
The x or the y.
Yeah, with just one operation.
Like in that example from the text,
Okay.
x plus 5 equals 10.
Oh, yeah. A classic.
Subtract 5 from both sides.
Right.
And bam, x equals 5.
Exactly. You got it.
But then we have multi-step equations. And that's where things start to feel a bit more, well, multifaceted.
Yeah, they get a little trickier. For sure.
Like, can you give me an example of one of those?
Yeah, let's take 3x plus 2 equals 11.
Okay.
Now you need a couple of steps to get that x all alone.
Okay.
First, you got to subtract 2 from both sides.
Right.
That leaves you with 3x equals 9.
Gotcha.
Then you divide both sides by 3, and boom, you've got your answer, x equals 3.
Okay, so it's kind of like
Yeah.
untangling a knot. You
Yeah.
carefully undo each step to reveal the answer at the center.
That's a great way to put it.
Okay. But then the book throws a real curveball.
Oh, what's that?
Solving equations with variables on both sides.
Yeah, those can be a little intimidating at first.
My brain's already in a twist.
I bet.
Can you walk me through how that works?
Sure. So imagine an equation like 2x plus 5 equals 4x minus 3.
Okay.
See, now you've got that pesky x on both sides.
Yeah, on both sides.
The key here is to move all the x terms to one side of the equation and all the constant terms to the other side.
Like you're sorting them.
Exactly. And as always, you got to keep that balance in mind, whatever you do to one side.
They'll do it to the other.
You got it.
So you gather the x's on one side, the numbers on the other, and then you're good to go.
Pretty much. You'll be able to isolate the x and solve for it.
This is making way more sense now.
Good. I'm glad to hear.
Okay, but we're not done yet.
Yeah.
The book also mentions
What else?
literal equations and formulas.
Yes.
Honestly, those sound a bit intimidating.
I know they have kind of a scary name.
They do.
But they're not that bad. Don't worry.
Okay, well, what are they?
So basically, a literal equation is an equation with multiple variables.
Okay, more than one.
Right. And instead of trying to find a specific number as the answer,
Okay.
you rearrange the equation to solve for one variable in terms of the others. Like, think about famous formulas. You know, like E equals mc squared.
Right, or the area of a circle.
Yeah, exactly. Area equals pi r squared.
Okay.
Those are literal equations.
Oh, I see.
They're all about expressing the relationship between different variables.
So it's less about finding a concrete number and more about seeing how these variables relate to one another.
Exactly.
Like if you knew the area of a circle, you could rearrange the formula to figure out the radius.
Precisely.
Yeah.
Literal equations give you that flexibility to manipulate formulas and solve for whatever variable you need.
And that's useful for?
Oh, tons of things.
Yeah.
Physics, engineering, finance, pretty much any field that uses math.
Algebra really is the Swiss Army knife of math.
I like that.
All right, so moving on, the book also talks about
Let me guess.
ratios, rates, and proportions.
Oh, yeah, those are fun.
Am I sensing a theme here? Is algebra all about, like, comparing and relating things?
You're spot on. Ratios are at the heart of comparison. They tell us the relationship between two quantities.
Okay.
Think of like a recipe. 2 cups of flour to 1 cup of sugar.
Okay, I see.
That's a ratio. It shows you the proportion of ingredients you need.
Gotcha. So how do rates and proportions fit into all this?
So a rate is just a specific kind of ratio.
Right.
It compares quantities with different units.
Different units.
Right, like miles per hour. It's comparing distance you travel to the time it takes to travel that distance.
Okay, makes sense.
And proportions are statements that 2 ratios are equal.
Oh, so like if I'm baking and I double a recipe, the proportion of ingredients stays the same.
Exactly.
Even though the quantities change.
Right. So you could use a proportion to figure out exactly how much of each ingredient you would need.
Okay, so proportions are all about scaling things up or down while keeping the same relationships between quantities.
Exactly.
And algebra gives us the tools to solve for any unknown in those proportions.
Precisely.
I'm really getting the hang of this now.
I think so.
But there's one last thing.
All right, what's that?
The book mentions percent problems.
Oh, yeah, percentage.
How does something as seemingly simple as percentages tie back into algebra?
Percentages are like ratios in disguise.
Oh, okay.
They're just a part out of 100.
Yeah.
You can express them as decimals or fractions, and you guessed it. We can use our algebraic equations to solve all sorts of percent problems.
So like when I'm shopping and I see a sign that says 20% off, that's actually an algebra problem waiting to be solved.
You got it. Whether you're calculating discounts, interest rates, or tips, algebra gives you the tools to tackle percentages head on.
We've covered so much ground today.
We have.
It's amazing to see how all these seemingly different concepts, equations, ratios, percentages are all tied together by the powerful language of algebra.
Algebra is the key.
Totally.
Yeah.
And it's not just for textbooks. It's something we can actually use in our everyday lives.
Absolutely. And here's something to think about. As you become more fluent in this language of algebra, you'll start to notice those problem-solving skills showing up in unexpected places. You'll approach challenges in a different way, whether you're negotiating a deal, analyzing data, or even just planning your next vacation.
Wow, algebra really is the gift that keeps on giving.
You said it.
Thanks for joining me for this deep dive into algebra.
My pleasure, anytime.
We've learned a lot today. I can't wait to see what other problem-solving adventures await us.
Me too. It's going to be fun.
Until next time, keep those algebraic equations flowing.
And those problem-solving skills sharp.